Hello students, welcome back to today's class on probability and we are in lecture number 2. In the last class we discussed what is probability and also we discussed a couple of applications based on that, and let's try to discuss more applications on what all we have learned in the last class. My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what is probability? What we have discussed in the last class, right? So we have discussed probability is the occurrence, right? Is the percentage of the chances to win. Right, we have discussed probability in the normal terms and we discussed a couple of examples too. Right, I'll give you one more question so that you can understand more better about this. With this, we have stopped the last class. Once again, let's try to continue with that step. Right, what is the probability that a number selected from the numbers 1, 2, 3 and so on 15 is a multiple of 4? Number which is selected is a multiple of 4. So what is that meaning? Okay, so 1, 2, 3 and so on 15. Here we have 15 numbers. Let me write all those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 is a multiple of 4. It's a multiple of 4. So what is that multiple of 4? So 4 into 1, 4 into 2, 4 into 3. Do we have any other number? Do we have 4 into 4? No. Right? So what is the probability that number selected from the numbers 1, 2, 3 and so on 15 is a multiple of 4. So we have 1, 2, 3 numbers. So 3 by how many total number of numbers? 15. So 3 by 15, 3 1s and 3 5s. So which is a 1 by 5. 3 by 15 which is a 1 by 5. Right? So let's try to continue one more question. Ashrita throws 2 normal 6-faced dice. So what is that 6-faced die? So these are called dice, you know that, right? When you play the Ludo game or whatever the game is, you use this one. Find the probability of getting the sum of the numbers on both the dice at least 11. At least means the count should not fall below 11. The count may be 11 or maybe 12, but not more than that. Why? Why the number cannot be more than that? Because she's throwing 2 die. She's throwing 2 die. So 6 plus 6, the maximum they can get 6 plus 6 is 12. But here the question is at least 11. The probability of getting the number, sum of the numbers is at least 11. So let's try to see what are the cases. Let me write all the cases. So we have total 2 dice. One die will have 1 to 6 options and other one will also have 1 to 6. Let me write all the outcomes for you. What are all the chances we are having, right? So let me write down this. So there are 6 and 6. So 6 into 6, we generally get 36 possible outcomes. 36 possible outcomes. Let me write all this, right? So 1, 1 is one case where when you throw both the dice, the first die giving you 1 and the second die give you 1. Total is 2. In the same way we have 1, 2. In the same way we have 1, 3. 1, 4, 1, 5, 1, 6. Right? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5 and 2, 6. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5 and 3, 6. The next one 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. And the last one we have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6. So total at least 11. We should get at least 11. So not only total, how many cases are there? Don't take this as 21, 22, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 6, 3, 5, 3, 4, 3, 3, 3, 2, 3, 1, right? So all these are the numbers shown by both the die. Right. Okay, so now we should get a sum of at least 11. If we should get a sum of at least 11, so carefully observe, I'll try to plot which are the numbers that we're having. So where we get the count as 11 or 12, 1 plus 1 is 2, 1 plus 6 is 7, so we don't get anything here. 2 plus 1, 3, 2 plus 6, 8, no. Let me cancel that, which are not possible. These are not possible, these are not possible. 3, 1 is 4, 3, 6 is 9, no. 4 plus 1 is 5. 4 plus 6, 10. Still we didn't reach 11. So 5 plus 5, 10. 5 plus 6, 11. 5 plus 6. Okay. So 5, 6 is one option. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5. 6, 5 is 11. And 6, 6 is 12. So that means out of the total 36 cases, whatever we are having here, out of that only 3 are favorable to us. Out of the total 36, we are having only 3 are favorable to us, right? So out of 36, only 3 are favorable. So number of favorable by the total number of cases 3 by 36, that is 1 by 12. So that is a probability. 1 by 12, you can leave it like that, or you can try to bring that into decimal numbers by dividing 1 by 12, right? So that is how you can try to bring all these relations, all these cases. We totally get 36 cases here. Right, 2 dice. Next one. A coin is tossed 3 times. A coin is tossed 3 times. So when you toss a coin, you either get head or tail. You know that, right? You either get a head or tail. That means when you're throwing 3 times, all 3 cases are important. The first one you may get tail. The next you may get head. The next you may get head. So we need to write all these possible cases such that finally, we need to understand, or we need to calculate the number of cases where getting head and tail alternatively. That means the first if you get head, the next you should get tail. And again you should get head, or tail, head, tails. Okay, so all those cases. Now, let me tell you how many actual total outcomes are possible. Total outcomes, I'll write you here. I'll tell you here. So let's see here. Toss 3 times. So let's say this is the first time, the second time, and this is the third time. So let me write all this 1, 2, 3. The first one, a coin is tossed 3 times. What is the probability of getting head and tail at least alternately? Tail alternately. So let me write all the cases. Tail, tail, tail. That is one case. When all the 3 coins tossed will give you tails. Tail, head, head, tail, and head, head. Right? Tail, 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 tail. So these are the first 4 possibilities. Next, H, T, T, head, tail, tail, head, tail, head, 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 tail, and head, head, head. So this is how all the 8 outcomes will be there. Now, what is the probability of getting head and tail alternatively? Head and tail alternative, right? So you can see here, these are all tails. No, that will not happen. That will not count to us. So this is wrong. Tail, tail, head. What is the probability of getting head and tail alternate? But here, see here, tail is there, tail to tail. We are not getting any difference, right? Tail to tail, which is not alternatively. So even this is wrong. Tail, head, tail, it is correct. T and then H and then T. This is correct. That is the first one. The next, tail, head, head. That is wrong again because we are getting 2 heads alternatively. Okay. Head, tail, tail, 2 tails. Wrong answer. Head, tail, head. That is correct. Head, tail, head. So that is correct. That is how you get those 2. The alternately heads and then tails and then heads. Right. Next, head, head, tail. That is wrong. Head, head, head. Even that is wrong. So how many cases are the total? Favorably, we have 2 cases, but the total number of cases is 8. So 2 by 8, which is 1 by 4. 2 by 8, which is 1 by 4. So you have total of 1 by 4. I mean, total 2 cases out of 8 cases. The probability is 1 by 8. The probability is 1 by 8, right? Sorry, 1 by 4. Moving ahead, a die is thrown. Find the probability of getting an even number. You know what is a die? What happens when we throw a die? Okay, so throwing a die, when we throw, we get either 1 or 2 or 3, 4, 5 or 6. Now the question is, find the probability of getting an even number. Find the probability of getting an even number. So this is 1, this is second one, and this is third one. So these are 3 numbers, right? Find the probability of getting an even number 1, 2, 3. So we have total 3 cases. So 3 by 1, 2, 3, 4, 5, 6, 3 by 6, which is 1 by 2. 3 by 6, which is 1 by 2, right? So find the probability of getting an even number is 1 by 2, or if you can divide 1 by 2, you will get 0.5 as the probability. In general, probability we always represent in fraction or in decimal. Both are correct. That's not a mistake, right? You sometimes write 1 by 2, sometimes you write 0.5, right? The next one. The probability of all the events in a sample space adds up to 1. Yes, this is exactly correct. The probability of all the events in a sample space means, let's say one event, let's say one experiment. Tossing a coin, that is one experiment. Throwing a die, that is one experiment. Right? In that, what all the probabilities we are talking about? So sum of all those will add up to 1. Sum of all those will add up to 1. So that is what this statement gives you. let's say probability of getting a tail or probability of getting some A, let's say probability of A is, let's say, 0.7, and A comma B are the events. If not A, then B. If not B, then A. There are two outcomes here, like head and tail or something like that. Okay, so if I want to find probability of B without giving any other information, but I know that these two are the events in the same space, right? So then I can say that these two should add up to give you 1. So definitely probability of B will give you 0.3. Definitely probability of B will give you 0.3. 0.7 and 0.3, that will give you 1. Right. So moving ahead, right, so that answer is yes, that's exactly correct. 11 bags of wheat flour, each marked 5 kg, actually contain the following weights of flour. Okay, so there are 11 bags of flour, but actually we thought that each one is of 5 kgs. But here what happened? 1 2 3 4 5 6 7 8 9 10 11 bags are there, but not all of them are equal to 5. They are either greater than 5, or they're less than 5, or they're also equal to 5. Less than 5 cases there, greater than 5 cases there, equal to 5 is also there. Now the question is, what is the probability that any of these bags chosen at random contains more than 5 kg of flour? What is the probability that any of these bags chosen at random contains more than 5 kgs of flour? So in this case, tell me how many bags are there whose weight is more than 5. I know the total count is 11. That there is no change in that. But how many are greater than 5? So 1, 2, 3, 5 is not greater than 5. That is the only mistake you do. 5 is equal to 5. The question is more than 5 kgs. So 5 cannot come. 5.06 can come. 5.08 can come. 5.04, 5.07. So now tell me how many cases, right? So 1, 2, 3, 4, 5, 6, 7. So total, out of 11 we are having 7 cases. Out of 11 we have 7 cases where the probability is more than 5 kgs. The probability is more than 5 kgs. 1, 2, 3, 4, 5, 6, 7. Okay, right? So that is how you try to find the probability. Very simple question. Let me tell you one more. In a survey of 364 children aged 19 to 36 months, right? We are taking a survey. It was found that 91 like to eat potato chips. Okay, so many of you like that. Many of you like potato chips. Even I like that, right? So 91 liked to eat potato chips. If a child is selected at random, the probability that he or she does not like to eat potato chips is. See, out of the total 364 children, we know 91 children already like that. Already like potato chips. But the question is, how many does not like? So we need to find the number of students who don't want that, number of people who don't want that. 4 minus 1 is 3. 36 minus 9, if I'm not sure, 16 minus 9 is 7, and 273. Is that correct? 16 minus 9, correct? 273. Now the question is, what is the probability that he or she does not like to eat potato chips? So 273 is the number of people who does not like potato chips divided by the total count is 364. The total count is 364. But still, we have answers like 0.25, 0.50, 0.75, 0.80. Let me calculate that. Okay. So we need to cancel that maybe with 9. This is with 9 and 1, right? Let me check with 91. 91, because 91 is also there, maybe some hint. 91 3s, 3 1s 3, 9 3s 27, exactly correct. And what is 91 4s? Now 4 1s 4, 9 4s 36, 364. Okay, so this is just a hit and trial method. I thought of 91 because 27 and 3, it is a 9 type. With 9 we can cancel that. I mean, with 3 we can cancel that. 3 91s, and here also with 3 we can cancel that. It is again 91s. Okay, I mean to say with 4s. Okay, so which is equal to 3 by 4 when you divide with 11, when you divide with 91. So 3 by 4 is a 0.75. I will tell you how is 3 by 4 is 0.75. 4 and 3, so 0.04. 4 7s are 28. You're left with 2 0. 4 5s are 20. 4 5s are 20. So that is a 0.75. That is a 0.75. That is how you try to bring all this, right? So 0.75, option C is the correct answer. Let's move to more questions on these applications. In a sample study of 640 people, so there are total 640 people who are studying, okay, it was found that 512 people have a high school certificate. Out of 640, 512 people have high school certificate. If a person is selected at random, the probability that the person has a high school certificate, the probability that the person has, so 512 are the people who have the same probability is being asked. So we need to find 512 by 640. So we need to find what is the value, 0.5 or 0.6, 0.7 or 0.8. Let me calculate that. Let me divide that with few numbers. Maybe with first we can cancel with 4, I think. So 4 ones are 4, 4 twos are 8, then with 3, 4 8s, 128 by 460. 4 ones and 2, 4 16s, 160, 128 by 160. I think we can cancel once again with 4, right? 4 3s and 4 2s, and this 4 40s, 32 by 40 with 8, I guess, right? With 8 you can cancel. 8 4s, 8 4s 32 and 8 5s. So 4 by 5, let me calculate that. 5 and 4, 0.05, 8s are 40. 5 8s are 40, that is enough to say that 0.8 will be the probability. 0.8 is the probability of the people selected having high school certificate. But if the same questions are asked for people who don't have high school certificate, instead of doing that again complete thing, as you know the total sum should be 1. So 0.8 is the people who have the certificate and 0.2 are the people who don't have the certificate. 0.2 people are the people who don't have any certificate, right? Next one. A bag contains 16 cards bearing numbers 1, 2, 3 and so on to 16 respectively. One card is drawn at random. What is the probability that a number is divisible by 3? It's a very, very simple question. A bag has 16 cards, right? And every card has a number 1, 2, 3 and so on till 16. So now, from 1 to 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is the probability that a number is divisible by 3? What is the probability that a number is divisible by 3? Right? So by 3, so 3 is divisible by 3, 6 and then 9 and then 12 and then 15. 1, 2, 3, 4, 5. So total 5 out of the total 16 numbers. So 5 by 16 is the probability. 5 by 16 is the probability of a number selected at random between 1 to 16 is divisible by 3. Is divisible by 3, right? Okay, so moving ahead, a die is thrown 300 times and odd numbers are obtained 153 times. A die is thrown 300 times. So 300 times you're throwing and odd numbers are being obtained 153 times. Odd numbers are 153 times. Then find the probability of getting an even number. You know, either we get odd number or whether we get an even number. There is no other possibility. So definitely, if odd numbers are 153, even numbers will be 300 minus 153. 300 minus 153, so 10 minus 3 is 7, again 9, so 9 minus 5 is 4 and 2, right? 153 and 247, so that will give you 300. Now the probability of getting an even number. What is the even number here? Even numbers are 247, so 247 by 300. If you can cancel, please try to cancel that. 7 plus 4, 12, then 14. I don't think we can cancel 5. But if you have any other multiple, so please try to cancel with that. Okay. So that is the probability of getting an even number. Now, okay, so I think you understood all these lectures, right? All these questions. In the coming class, we're going to discuss more applications based on probability, and we're going to discuss more advanced level applications on all the probabilities, right? This is a very, very important topic and very beautiful and very interesting topic. Thank you so much, students. I hope you understood all this. In the coming class, we're going to discuss more about all this. Thank you so much.
Hello everyone. So today we'll again be continuing with acceleration due to gravity. Okay, my name is Shashin Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. So first of all, what all did we learn in the previous class? We learned about something called as G. What is G? G is acceleration due to gravity. That is, when there is gravitational force acting on an object. And gravitational force by what? Gravitational force by Earth. Gravitational force by Earth. So in simple terms, this is Earth. Near the surface of Earth, if there is an object, on this object, there will be what? Gravitational force. And whenever there is a force, there will be what? There will be acceleration. Yes or no? Acceleration due to gravity is equal to gravitational force upon m. What is m? M is mass of object, not of Earth. So we have done the derivation and we got a formula. G is equal to capital G me upon re square. What is me? Me is the mass of Earth. Re is the radius of Earth. Right, and small g is the acceleration due to gravity. And as you can clearly see here, there is a clear difference between small g and capital G. Small g is acceleration. Small g is acceleration. And what is the SI unit of acceleration? Meter per second square. Whereas capital G is a constant, universal gravitational constant. Both of them are completely different. And on the Earth, what is the value of small g? That is the acceleration due to gravity. It is 9.8 meter per second square. Valuation of small g is going to be 9.8 meter per second square. Got it? And how do we get this? By substituting the value of capital G, the value of me and the value of re. By substituting all those values, we get this. Okay, so we have done the derivation and we got this formula. We got this value and that value should be remembered as well as this formula. Both of them should be remembered. Okay, good. Now we'll go into a value of acceleration due to gravity on the moon. See, even when you stand on the moon, or if there is an object on the moon, on that object, for example, here we have a ball. A ball is on the moon. Okay, the ball is appearing big, but yeah, let's think of it as an object. There's a ball on the moon. On the ball, there will be a gravitational force. Gravitational force will be there. What? On what? On the ball. By whom and who will apply that gravitational force? Earth will apply that gravitational force. You can say by, not Earth, sorry, moon. So gravitational force on the ball by the moon will be there. And if there is gravitational force, there will be acceleration. So the acceleration due to gravitational force of the moon is nothing but acceleration due to gravity on the moon. Right, so how do we find it out? It's very simple. See, on Earth, what is the formula for acceleration due to gravity? It is capital G mass of Earth upon radius of Earth square. But if I need the same on moon, what will we do? We'll take acceleration due to gravity on moon. That's fine. The only thing is, in place of Earth, we take moon. So mass of moon upon radius of moon square. mm is mass of moon. rm is radius of moon. gm is acceleration due to gravity on moon. The similar formula, but the values change, the terms change. And obviously mass of moon is different from mass of Earth. Radius of moon is different from radius of Earth. That means these two values will be different. These two values will be different. Okay. The table is given here. The table containing all the values is given here. Right. So here it should be what? It should be meters. So radius is 1760 kilometer. If I convert that into meters, I'll get it as 1.76 into 10 power 6 meters. Meter is the SI unit of length. Mass is given 7.4 into 10 to the power 22, capital G, we know the value. So let's find out acceleration due to gravity on moon. Yes, So what is the formula? Capital G, mass of moon upon radius of moon square. Capital G, as we know, is 6.67 into 10 power minus 11 into mass of moon. How much is that? 7.4 into 10 power 22 SI units. Upon, then what do we have? 1.76 into 10 power 6. But radius of moon is given, we have to take its square, so it comes twice. 1.76 into 10 power 6, again multiplied with 1.76 into 10 power 6. Now all that left is to do the calculation. You can split them. 6.67 into 7.4 divided by 1.76 into 1.76 into 10 power minus 11 into 10 power 22 upon 10 power 6 into 10 power 6. You can do the calculation, right? We have done the calculation. I have shown the calculation for acceleration due to gravity on Earth. This I will leave it to you, and this, if you solve it, you'll get the value as almost 1.6 meter per second square. Right, so what is the value of acceleration due to gravity on moon? It is 1.6 meter per second square. Okay, so the steps are shown here, the same steps that I have done. The formula, substitute and solve. You'll get what? You'll get it as 1.6 meter per second square. Clear? I'll leave the solving part to you, so please solve it. Okay, and ultimately solving part will be a bit lengthy but easy, because see, multiplication and division. Multiplication and then division. Okay, doable, easily doable, so do it. Good. Now, we got the value of acceleration due to gravity on moon. What we will do is we'll compare this value with the value of acceleration due to gravity on Earth. Let's see that here. If I just take the ratio, acceleration due to gravity on moon is 1.6. Acceleration due to gravity on Earth is 9.8. Which is equal to what? If you multiply with 10 on both on the numerator as well as the numerator, 1.6 into 10, 16, 9.8 into 10, 98. Now how much is that equal to? Now look at this. What is 16 into 6? It is equal to 96. Right, so this I can say that it is almost equal to 16 by 96. It's an approximation. We are going for an approximate value, not an exact value. 98, I'm replacing it 96. 98 and 96 are close. Right, so approximation. So what is 16 by 96? It is 1 by 6. And what do we have here in the LHS? Gm by Ge. So if I take Ge to that side, I'll get acceleration due to gravity on moon is 1 by 6 times acceleration due to gravity on Earth, or almost equal to 1 by 6 times the acceleration due to gravity on Earth. Simple calculation use. Obviously there is an approximation involved. There is what? An approximation involved. And this is the reason why we say that acceleration due to gravity on moon is 1/6. 1/6. 1 by 6 is 1/6 that of acceleration due to gravity on Earth. Clear? Good. So now we understood about what? We understood about acceleration due to gravity. Now we'll go into free fall, and whenever we have acceleration, we'll have a change in velocity. Right? We'll have a motion. So motion under acceleration due to gravity, or motion due to gravitational force. That's what we'll be learning now. Right? And that is called as free fall. What is that called as? Free fall. So you can see that here a ball is jumping. It's going up, coming down, going up, coming down, up, down, up, down, up, down, up, down. Right? That is free fall. At least for most of the part it is free fall. So what does free fall actually mean? What it means is it is a motion in which there is only gravitational force acting. So free fall is the motion in which gravitational force by the earth is the only force acting and no other force. And when we say no other force, no resistance due to air, no wind, nothing. Okay, so when the ball is touching the ground, when the ball touches the ground will apply force on it, which is not gravitational, by the way, right? So that means when the ball touches the ground, it is not in free fall. When the ball is in air, then we say it is in free fall. Okay, so no other force should act. There is one simple point. There is only one point, in fact, that is, there is only one force, and that force is gravitational force by the earth. All the other forces are neglected or do not exist. But practically they are neglected. So when you throw a body upwards, a body thrown upwards in air, while it is in air, not in our hands, not touching anything else, when it is in air and going up, then for most of the part we can neglect air resistance because it will be very less. When compared to gravitational force, air resistance is less, so you can neglect air resistance in that case. Okay, and then again another case, a body thrown downwards, again the same thing, when the body is in air, not touching the ground, not touching anything else, then we can say that the body is in free fall. Only one condition, as I told you, what is free fall? Only gravitational force should act. Okay, so we'll go into that, but understand this, if only gravitational force will act, if only one force will act, then the net force is equal to gravitational force. That implies that acceleration, which is equal to net force upon mass, will be equal to gravitational force upon mass. And what is gravitational force upon mass? Acceleration due to gravity. So in free fall, the main point is the acceleration will be acceleration due to gravity. So in free fall, we will always know the acceleration. What is the acceleration? It is acceleration due to gravity. You know the value, 9.8 meter per second square. That is a speciality of what? Free fall. Clear? Good. We'll discuss about those points, some important points regarding that. Before that, let's watch a video. Okay, in fact, two videos. So, here what do we have? This is how feathers and a heavy ball fall in the presence of air. So, let's watch the video. Watch it carefully. So, what we do is, or what is done in this video is, there is a heavy ball as you can see and there are feathers. They are dropped. And now they are dropped in normal room where there is air. Okay, let's see what happens. Normally, ball falls first and feathers fall slowly. Feathers fall slowly. But in the second case, or in this video, what is done is, let's say there is a room, the room in which the experiment is done. Okay. In this room, air is completely removed. So what is there? Vacuum. Air is removed. So if air is removed, no air resistance, no wind. So which force will act on the feathers or on the ball? Only gravitational force. Only gravitational force will act on it. Understood? Yes, that is what we need. Because the previous case, when they fall in the presence of air, right, then there is air resistance, there is buoyancy, there are many forces, not only gravitational force, there are other forces. That is the reason why feathers fall slowly. But here in the video that we are going to watch now, there is nothing, only vacuum, and see how they fall. Watch it carefully, it will be very interesting. So watch it. Watch them. And what can we notice? See, when there is no air, the ball and the feathers are falling exactly at the same time. That's the beauty of this experiment. That is the beauty of this video. What does that mean? If they're falling exactly at the same time, their accelerations should be equal. Their accelerations should be equal. And what will their accelerations be? It will be acceleration due to gravity, because there is no other force. So in this case, you can clearly say that A is equal to G. Their acceleration is equal to acceleration due to gravity. You can say that only gravitational force acts. Okay, it's a very costly experiment, by the way. Okay, so the complete video is here. You can watch it. Please do watch it. It's very interesting. Okay, got it? So what does that prove? This proves free fall. This proves that on every body there is only one acceleration, that is acceleration due to gravity. Acceleration due to gravity for every body is the same. It does not depend on mass. But normally in air, heavy ball falls fast and feathers fall slowly. That is because of what? Forces due to air, not because of gravity. Clear? Good. So that's free fall. So we have a simple question for us here. Is a flying plane in free fall? Yes or no? A plane is flying. It's going up, it's coming down, or it is in air. Is it in free fall? Yes or no? What do you think, everyone? Is a flying plane in free fall? And the answer will be no. Why? Because see, free fall will mean only gravitational force should act. Free fall will mean only gravitational force should act. But when a plane is flying, we know that there are forces by the engine also. Right? The engines also exert forces. One simple example, there will be force by air, there will be force by engines, many things, many other forces, right, in addition to gravitational force. So is the gravitational force only force acting? No. So is it in free fall? No. Good? Okay. Now, in free fall, we'll have two cases. One, the ball going up and the ball coming down. So we'll go into individual cases. But let's first go into a simple case. So if a ball is thrown upwards, you can clearly distinguish them. One is the upward journey and the other is the downward journey, or upward motion or downward motion. So start imagining. While you throw a ball up, when you throw a ball up, what happens? See this. It will be going up, so its velocity will be upwards. Its velocity will be upwards. But as we know, there is only one force acting, gravitational force. Gravitational force is downwards. So acceleration or acceleration due to gravity will be downwards. And in both the cases, you can say A is equal to G. And what about the value of capital G? Is it constant? Yes, it is constant. G is constant. And if G is constant, which type of motion it is? It is uniformly accelerated motion. The same thing is applicable here also. Right, we'll go into that part, don't worry. Where is the upward motion? And while you throw a ball up, what happens to its speed? It decreases or it increases while it goes up? It decreases. See here. Velocity is upwards, acceleration is downwards. Both of them are in opposite directions. That means it is the case of retardation. And what happens in retardation? Speed decreases continuously. Speed decreases. So let's say at the bottom, when you are throwing up, right, the initial speed of the ball is 20 meters per second. So as the ball goes up, its speed keeps on decreasing, 20 to 19, 19 to 18, 18 to 17, so on and so on. 20 to 15, 15 to 10, 10 to 5, 5 to 4, 4 to 3, 3 to 2. Still decreasing, 2 to 1, still decreasing, 1 becomes 0. Right, so at the topmost point, the speed will be 0. The topmost point, speed will be 0. V is equal to 0 at the topmost point. Clear? So for the upward motion, these are some of the main points. So here if you can look at that, The velocity is upwards and acceleration due to gravity is downwards. So here acceleration, should we take it as positive or negative? Here the speed is decreasing continuously, so it is retardation. So in calculations, in formulae, when you substitute, you have to substitute A as equal to minus G. Retardation, negative acceleration. Clear? Okay. Then for the downward journey, yes or no? What happens in downward journey? Velocity will be downwards. Well, it is coming down. Velocity will be downwards. Acceleration due to gravity is downwards. Right, so both of them are in same direction. You can say A is equal to plus G, positive acceleration. Speed increases with time. Speed increases. And speed is increasing, that's fine. And one more point is, the same point is applicable here, that the acceleration due to gravity is constant. So which motion it is? Uniformly accelerated motion. Now why are we discussing about uniformly accelerated? Because whenever you have uniformly accelerated motion, you can apply the kinematic equations of motion. V is equal to U plus AT. S is equal to ut plus half at square. V square is equal to u square plus 2as. All those formulae can be applied, so we will try applying them. Okay, good. Let's continue. So for downward motion, we are discussing about downward motion. First, okay, let's say an object dropped from a height h. An object dropped from height capital H. We are considering that case. Okay. So consider this. If I take this pen, now in my hand, what is its speed? Is it moving? No. So its speed is 0. So the topmost point, this will be 0. When I drop it, what happens? It comes down. But at the topmost point, what will its speed be? 0. So here, if this is the object, it is falling down towards the ground. So here the initial velocity itself is 0. U is equal to 0. Got it? And when it reaches the ground, what is the displacement? Displacement is the distance or length of the line joining the initial and the final point. So this here is initial point, this here is the final point. So this length is the displacement, but that length itself is the height. So I can say that S is equal to capital H, displacement is equal to height. And the acceleration is downwards, velocity is downwards, so acceleration is positive. A is equal to G. So using these three things, whenever you have three quantities, the other two you can easily get. Right, let's calculate final speed first. Or you can say speed before touching the ground. If it touches the ground, it is not free fall. So just before touching ground. So displacement is how much? H. Acceleration is G, U is equal to 0. So can I use V square is equal to U square plus 2as? We can. V square is equal to U becomes 0 plus 2 into acceleration is G, displacement is H. So 0 plus 2gh, 2gh, V square is equal to 2h and V is equal to under root of 2gh. There you have it. So we got the final speed or just before touching the ground. If you need then time taken, that also you will get. Time taken. Which formula do we use? You can go for any formula. V is equal to U plus AT, you can. S is equal to UT plus half AT square, you can. So I'll go with S is equal to UT plus half AT square. But U is 0. right? S is h. So h is equal to half into g into capital T square. Capital T is total time. That's it. Right, so if I rearrange this, what happens? I'll get T square is equal to 2h by capital G, or time of flight is equal to under root of 2h by G. Got it now? All of them. Sir, should I remember the formula? Capital T and the final velocity. If you can, please remember it, or else you can ultimately solve it using the kinematic equations of motion themselves. Okay, let me show them to you. Right. So using the conditions that I have here, 1, V is equal to U plus AT. What does this become? See, U is equal to 0. That means V becomes equal to GT, because A is equal to G, positive G. Then we have S is equal to UT plus half AT square. You can say displacement is equal to, again, U is 0, half AT square, A is G, so half GT square. Then V square is equal to U square plus 2AS, again, U is 0, so you can say V square is equal to 2AS. And A is G, so 2GS. The only thing that you have to remember is displacement can be expressed in terms of time. How? See, if a body, right, this is the ground. Let's say this is the initial point. This is at time t, or let's say final. The complete height is h. This height is small h. What is displacement going to be? Displacement will be from initial to final. So from I to f, this is displacement. How much is that? Capital H minus small h. And you'll get the answer. You need not remember anything special in this case. You have to understand the things. A is equal to G, U is equal to 0. You have to understand them. Once you understand them, you can easily solve it. Okay. So what all we have done, everything is given here. You can go through them. Okay. But let's solve a problem to make things easier. A car falls off a ledge and drops to the ground in how much time? 0.5 seconds. Let G is equal to 10 meter per second square. That's fine. What is the speed on striking the ground? Let's do it. And we have other two also. Let's do it first of all. First thing would be given information. But before going for given information, draw the diagram. It's like this. A car is falling off, right? Topmost point. Here the initial speed is 0. Then it falls down. What is given here? It drops to the ground in 0.5 seconds. So this time taken is how much? 0.5 seconds. Acceleration due to gravity will be downwards. We have to find the speed on striking the ground. So given information, U is equal to 0. Total time of flight is 0.5 seconds. And A is equal to G. Here downward acceleration, velocity downward, speed will increase, positive. A is equal to G, and G is given as 10 meter per second square. Do we have three quantities? 1, 2, 3. So if you have 3, you will get the other 2. So which formula do we use? We use V is equal to U plus AT. Simple, straightforward. U is 0, A is G, G is how much? 10, T is time 0.5. 10 into 0.5, it is going to be 5 SI on it, so 5 meter per second. And the answer is done. If you know the given information, use the kinematic equations and you will get the answer. Nothing much to do, nothing extra to do. Understanding the question and understanding the given information is important. That is the reason why we draw diagrams. This was case A. What is its average speed during 0.5 seconds? Now here, it is uniformly accelerated motion, yes or no? And for uniformly accelerated motion, average velocity is equal to V plus U by 2. We got V as 5, U as 0. So it is 5 plus 0 by 2, 5 by 2, that's going to be 2.5 meter per second. So we also have average velocity. Good. Then last one, how high is the ledge from the ground? Ledge is the starting point. So we have to calculate what? The total height in this case. We have to calculate what? The total height in this case. And how do we calculate height? We know that by the time it comes down, displacement is equal to total height. Yes or no? See, this is initial, this is final. What is the length between them? Height. Displacement is equal to maximum height. You just have to find out S. We can use any formula. You can go for S is equal to ut plus half at square. It's fine. But u is 0, so u is 0. S is capital H, half into acceleration is 10. So when it comes down, so for coming down, what is the time taken? 0.5. 0.5 is half. So half square, it is half into half. So you can clearly see 2 into 2 into 2, 8. So H is equal to 10 by 8 meters. 10 by 8 will be 5 by 4. That would be 1.25 meters. So there you have it. You have all three. We got all these three. I told you, right? Motion, all that you have to know is the given information and which formula to use. You'll get the answer. Okay. So we have understood downward motion. Now there is upward motion remaining. We'll do that in the next class. Okay, but please do practice problems on downward motion. Thank you. Thanks a lot.